Have you noticed the temperature rising lately? Across the globe, from the bustling cities to the icy poles, we're experiencing a warming trend. But why? What factors are driving this change in our climate? Join me as we delve into the science behind rising temperatures and explore the intricate ways our planet is changing. Our journey begins with a simple observation. The Earth is getting warmer. This warming, however, is not uniform. Some regions experience more dramatic shifts than others, and the consequences of these shifts are far-reaching. From melting glaciers to more frequent extreme weather events, the impact of rising temperatures is being felt around the world. In this series, we will investigate the causes of this global phenomenon. We will journey from the depths of our oceans to the heart of our rainforests, examining the delicate balance of our planet's systems and how they are being affected by human activities. We will also explore the potential solutions, from individual actions to global initiatives, that can help mitigate the effects of rising temperatures. At the heart of our planet's warming lies a natural process, the greenhouse effect. Like a warm blanket enveloping the Earth, certain gases in our atmosphere trap heat from the sun. These gases, known as greenhouse gases, allow sunlight to pass through, but prevent some of the heat from escaping back into space. This process is essential for life as we know it, keeping our planet at a habitable temperature. However, human activities have significantly amplified this natural process, leading to what we now call global warming. The burning of fossil fuels, deforestation, and industrial processes all release vast amounts of greenhouse gases, primarily carbon dioxide, into the atmosphere. These additional gases act like a thicker blanket, trapping more heat and causing the Earth's average temperature to rise. The consequences of this warming are far-reaching and interconnected. As temperatures rise, glaciers and ice caps melt at an alarming rate, contributing to rising sea levels. This, in turn, threatens coastal communities and ecosystems. Warmer temperatures also exacerbate extreme weather events like hurricanes, droughts, and heat waves, leading to more frequent and intense natural disasters. The impact of global warming extends beyond our immediate environment. Changes in temperature and precipitation patterns disrupt ecosystems, threatening biodiversity and the delicate balance of life on Earth. These changes also have profound implications for human societies, affecting agriculture, water resources, and human health. Addressing global warming requires a global effort. Reducing our reliance on fossil fuels, transitioning to renewable energy sources, and implementing sustainable practices are crucial steps in mitigating the effects of climate change. While global warming refers to the overall increase in Earth's average temperature, climate change encompasses a broader range of changes happening to our planet's climate system. It includes not only rising temperatures, but also shifts in precipitation patterns, increased frequency and intensity of extreme weather events, and rising sea levels. These changes are interconnected and influence each other in complex ways. Natural climate variability has always played a role in shaping Earth's climate. Factors such as volcanic eruptions, variations in solar radiation, and natural cycles like El Niño Southern Oscillation, ENSO, can influence global temperatures and weather patterns. However, the rate and magnitude of climate change we are currently experiencing far exceed the bounds of natural variability. Human activities are the dominant cause of the observed warming since the mid-20th century. The overwhelming scientific consensus points to the increase in greenhouse gas emissions from human activities as the primary driver of this unprecedented change. The impacts of climate change are already being felt around the world. From the melting ice sheets of Greenland and Antarctica to the increasing frequency of coral bleaching events, the evidence of a changing climate is undeniable. These changes pose significant risk to human societies and the natural world. Understanding the difference between global warming and climate change is crucial for developing effective solutions. While addressing global warming requires reducing greenhouse gas emissions, tackling climate change requires a multifaceted approach that includes adapting to the changes already underway. As we explore the complexities of rising temperatures, we must consider the unique challenges faced by urban environments. Cities, with their concrete jungles and bustling populations, often experience a phenomenon known as the urban heat island effect. This effect describes the tendency for urban areas to be significantly warmer than surrounding rural areas. Imagine flying over a city on a hot summer day. You would notice pockets of intense heat radiating from buildings, roads, and parking lots. These surfaces absorb and retain heat from the sun, creating localized areas of elevated temperatures. The urban heat island effect is driven by several factors. The dense concentration of buildings and paved surfaces reduces the amount of vegetation, which naturally cools the environment through evapotranspiration. The lack of green spaces in cities limits the amount of shade available, further contributing to higher temperatures. Human activities within cities, such as transportation, industrial processes, and energy consumption, also release significant amounts of heat into the environment. This anthropogenic heat, combined with the reduced cooling capacity of urban areas, exacerbates the urban heat island effect. The consequences of this urban heat burden are significant. Higher temperatures in cities can lead to increased energy consumption for cooling, reduced air quality, and adverse health impacts, particularly for vulnerable populations. Our journey to understand rising temperatures takes us to the very ground beneath our feet. The way we use land, from vast forests to sprawling urban centers, plays a crucial role in regulating Earth's temperature. Changes in land use, particularly deforestation and urbanization, can have significant impacts on local and global temperatures. Forests, often referred to as the lungs of the planet, play a vital role in regulating Earth's climate. Trees absorb carbon dioxide from the atmosphere during photosynthesis, acting as carbon sinks and helping to mitigate the effects of greenhouse gas emissions. Deforestation, primarily driven by agricultural expansion and logging, disrupts this delicate balance. When trees are cut down or burned, they release the stored carbon back into the atmosphere, contributing to the greenhouse effect and global warming. The conversion of natural habitats to agricultural land also impacts local temperatures. Croplands, especially those with dark-colored soils, tend to absorb more sunlight and reflect less heat back into space compared to natural vegetation. This difference in reflectivity, known as albedo, can lead to localized warming. Urbanization, the increasing concentration of populations in cities, further amplifies these effects. As cities expand, they replace natural landscapes with concrete, asphalt, and buildings, reducing the Earth's overall reflectivity and contributing to the urban heat island effect. Our planet's climate is a complex and dynamic system, influenced by a multitude of factors, including natural cycles that operate on various timescales. These cycles, driven by interactions between the atmosphere, oceans, and land surfaces, can cause fluctuations in Earth's temperature and influence regional weather patterns. One such cycle is the El Niño Southern Oscillation, or ENSO, a climate pattern that occurs in the Pacific Ocean and affects weather patterns worldwide. During an El Niño event, warm water accumulates in the central and eastern equatorial Pacific, leading to increased rainfall in the Americas and droughts in Southeast Asia and Australia. La Niña, the opposite phase of ENSO, brings cooler than average water to the same region, resulting in different weather patterns. Another significant climate cycle is the Pacific Decadal Oscillation, or PDO, characterized by changes in sea surface temperatures in the North Pacific Ocean. The PDO has two phases, a warm phase and a cool phase, each lasting for several decades. These phases can influence the frequency and intensity of El Niño and La Niña events and affect temperature and precipitation patterns in North America and other parts of the world. Volcanic eruptions, while relatively infrequent, can also have a significant impact on Earth's climate. Large eruptions inject sulfur dioxide into the stratosphere, where it forms sulfate aerosols that reflect sunlight back into space, leading to a temporary cooling effect on the planet. Solar variability, changes in the amount of energy emitted by the sun, can also influence Earth's climate. However, the current scientific consensus is that solar variability alone cannot explain the observed warming trend over the past century. As we delve deeper into the factors driving rising temperatures, we must consider the profound influence of human population growth and urbanization. The Earth's population has been steadily increasing, and with it, the demand for resources, energy, and space. This growth, particularly the rapid expansion of urban areas, has significant implications for global temperatures. Cities are centers of human activity, consuming vast amounts of energy for transportation, industry, and residential use. This energy consumption, primarily reliant on fossil fuels, releases large amounts of greenhouse gases into the atmosphere, contributing to global warming. Urbanization also alters the physical landscape, replacing natural surfaces with concrete, asphalt, and buildings. As we've explored, these materials absorb and retain heat, leading to the urban heat island effect and localized temperature increases. The increasing demand for goods and services from a growing population drives industrial production, transportation, and deforestation, all of which contribute to greenhouse gas emissions and impact the climate. As populations grow and urban areas expand, it becomes increasingly crucial to develop sustainable practices that reduce our environmental footprint. This includes transitioning to renewable energy sources, improving energy efficiency, and designing cities that are more resilient to the effects of climate change. Our modern world is powered by industry, a vast network of processes that transform raw materials into the products and services we rely on. While essential for our way of life, industrial activities are major contributors to rising temperatures, releasing significant amounts of heat and pollutants into the environment. At the heart of many industrial processes lies the burning of fossil fuels, coal, oil, and natural gas to generate energy. This combustion process releases carbon dioxide and other greenhouse gases into the atmosphere, trapping heat and contributing to global warming. Manufacturing, transportation, and energy production are among the most energy-intensive industrial sectors, accounting for a significant portion of global greenhouse gas emissions. These sectors rely heavily on fossil fuels, perpetuating our dependence on these finite and polluting energy sources. Beyond greenhouse gas emissions, industrial activities release other pollutants into the atmosphere, including particulate matter, sulfur dioxide, and nitrogen oxides. These pollutants contribute to air pollution and have detrimental effects on human health and the environment. Reducing the environmental impact of industrial activities requires a multifaceted approach that includes transitioning to cleaner energy sources, improving energy efficiency, implementing stricter environmental regulations, and promoting sustainable consumption patterns. Our exploration of rising temperatures takes us now to the microscopic world of aerosols, tiny particles suspended in the atmosphere. These particles, often invisible to the naked eye, play a complex and often contradictory role in Earth's climate system. Some aerosols can trap heat and contribute to warming, while others reflect sunlight and have a cooling effect. Aerosols can originate from both natural and human-made sources. Volcanic eruptions, dust storms, and sea spray are examples of natural processes that release aerosols into the atmosphere. Human activities, such as burning fossil fuels, industrial processes, and agricultural practices, are major sources of anthropogenic aerosols. The impact of aerosols on climate depends on their composition, size, and location in the atmosphere. Black carbon, a type of aerosol produced from incomplete combustion of fossil fuels and biomass, absorbs sunlight and contributes to warming. Sulfate aerosols, often released from volcanic eruptions and industrial emissions, reflect sunlight back into space, leading to a cooling effect. The net effect of aerosols on global temperatures is complex and still an area of active research. However, scientists agree that aerosols have a significant impact on Earth's climate and play a role in the observed warming trend. Our journey through the causes of rising temperatures leads us to the lush, verdant world of forests. These vital ecosystems play a crucial role in regulating Earth's climate, acting as massive carbon sinks that absorb and store vast amounts of carbon dioxide from the atmosphere. However, deforestation, driven by human activities, is disrupting this delicate balance, contributing to the increase in greenhouse gas concentrations and exacerbating global warming. Forests act as carbon sinks through the process of photosynthesis. Trees absorb carbon dioxide from the atmosphere and convert it into organic matter, effectively locking the carbon within their trunks, branches, and roots. This process helps to regulate Earth's climate by removing carbon dioxide, a potent greenhouse gas, from the atmosphere. Deforestation, primarily driven by agricultural expansion, logging, and infrastructure development, disrupts this natural carbon cycle. When trees are cut down or burned, the stored carbon is released back into the atmosphere. contributing to the increase in greenhouse gas concentrations and amplifying the greenhouse effect. Beyond their role as carbon sinks, forests also influence climate through their impact on albedo, the reflectivity of Earth's surface. Forests, with their dark green canopies, absorb more sunlight and reflect less heat back into space compared to lighter-colored surfaces like grasslands or croplands. Deforestation can alter regional and global precipitation patterns. Trees release water vapor into the atmosphere through transpiration, contributing to cloud formation and rainfall. Protecting existing forests and restoring degraded forest landscapes is crucial for mitigating climate change and preserving the vital ecosystem services that forests provide. Our exploration of rising temperatures would be incomplete without examining the role of methane, a potent greenhouse gas that traps significantly more heat than carbon dioxide over a given time frame. While often overshadowed by carbon dioxide in climate discussions, methane plays a significant role in global warming and poses unique challenges for mitigation efforts. Methane is emitted from a variety of sources, both natural and human-made. Natural sources include wetlands, termites, and the ocean. However, human activities are responsible for the majority of methane emissions, primarily through agricultural practices, fossil fuel production and use, and waste management. Agriculture is the largest source of methane emissions, accounting for about 40% of the global total. Livestock, particularly cattle, produce methane during digestion, a process known as enteric fermentation. Rice cultivation, another significant agricultural source, releases methane from flooded paddy fields. The production and use of fossil fuels, including natural gas, oil, and coal, are another major source of methane emissions. Methane leaks can occur during the extraction, processing, storage, and transportation of these fuels. Waste management, particularly landfills, is another significant source of methane emissions. Organic waste decomposing in landfills produces methane, which can escape into the atmosphere if not captured and utilized. Reducing methane emissions is crucial for mitigating climate change. Strategies include improving agricultural practices, reducing leaks from fossil fuel infrastructure, and implementing better waste management systems. As we've journeyed through the science of rising temperatures, we've uncovered a complex interplay of factors, both natural and human-induced, that are shaping our planet's climate. From the amplifying effects of greenhouse gases to the urban heat burdens faced by growing cities. The evidence is clear. Our planet is warming, and the consequences are far-reaching. But this is not a tale of despair, but a call to action. Just as human activities have contributed to the problem, so too can they be part of the solution. By understanding the causes of rising temperatures, we can make informed decisions and take meaningful steps to mitigate our impact on the environment. The time for action is now. Let us embrace sustainable practices, transition to cleaner energy sources, and work together to preserve the delicate balance of our planet for generations to come. Visit the link below to learn more about how you can be a part of the solution. These factors combined are leading to a steady increase in temperatures. Let's work together to reduce our impact on the environment and mitigate the effects of rising temperatures.